Hello, today we're going to be working on Unit E transformation sequences. Our content objective is students will be able to perform a sequence of transformations. Our language objective is students will be able to explain verbally the sequence of transformations performed. And why am I learning this? Well, it's important for real-world problems like the creation of video games. So let's remind ourselves real quick what a translation looks like. It's basically sliding a figure across a coordinate plane, such as this here. Now from this, I want to talk about things that it preserves. So the segment lengths are preserved, the angle measures are preserved. Notice the angle measurements did not change at all. They're exactly the same. The parallelism is preserved, meaning whatever lines were parallel remained parallel. The perimeter was preserved. It still has the same units around the shape as well as the area. So notice all of these features are preserved under translations. Okay, now what about reflections? Reflections is basically reflecting a figure across a line. Okay, we've only so far done vertical and horizontal lines. So here's an example of one. This one's being reflected off of the y-axis. Now notice here corresponding segments are preserved, so the lengths are preserved. The angle measurements are preserved. We really never talked about it too much, but kind of like translations, same thing with reflections. Angle measurements are preserved. Parallelism is preserved. Whatever lines were parallel remain parallel. The perimeter is preserved. Whatever the perimeter was of this shape remains the same in the second shape. And the area is preserved. So very similar to translation, all of these features are preserved. And then the last one we learned about was rotations. It basically rotates a figure across a fixed point. We've been doing everything around the origin. So here's an example of a rotation. Rotations also preserve segment lengths. Okay, corresponding segment lengths are still the same. Angle measurements are the same. Parallel lines are still the same, so parallelism is preserved. The perimeter is preserved and the area is preserved. So just like translation, just like reflections, all of these features are preserved under these three transformations that we've learned so far. Okay, so when translating, reflecting, or rotating a shape, the pre-image, okay, the beginning image, the new shape, which is the image, results in congruence to the original shape. So this means, again, corresponding parts are all congruent. So that means lengths and angles. So congruent figures means that figures have the same exact size and same exact shape, which is things that we kept looking at before. We always check to see, did it retain the same shape, same size, same orientation. So whenever they have the same shape and same size, they are congruent. Okay, so here's just a quick draft of the different types of transformations that we've already learned. So here is our pre-image here. This is a translation. It's being slid over. This one's a reflection. You can see that's being reflected off of the y-axis, and this one has been rotated. Okay, so these are just a quick visual of the different types of transformations that we've already learned. So at this point, let's go ahead and summarize the different types of transformations that we've learned so far. Let's look at the properties and the descriptions and the different transformations. So a flip basically is a reflection. A slide is a translation. A turn is a rotation. Now, when we look at the pre-image and image, which one keeps the same orientation? Reflection definitely does not retain the same orientation. Translations do. Rotations, the orientation is almost every single time has changed unless it's a complete 360. So I'm going to go ahead and say it has the same orientation with translations and occasionally rotations, but that's only with a 360-degree rotation. Okay, so reflections is not included because the orientations are reversed. So take a look at a reflection of this turtle. Okay, you'll notice one's looking to the left and one's looking to the right. Totally different orientation. Okay, which one needs a center and angle of rotation? I'm going to go ahead and say rotation. Okay, so far we've only done everything around the origin, but later down the road you may do rotations starting at a different point. Okay, it needs distance and direction. That's definitely going to be a translation. We need to know how far and in which direction, up or down. Needs line of reflection. That kind of gives it away. Definitely reflection. Okay, slopes of corresponding segments may change. Well, let's take a quick look at that previous slide that we had. Okay, so which slopes of corresponding sides will change? So let's look at PS. From PS to P prime S prime, the slopes are the same for translation. Definitely changes for reflection because this one's a positive 2 and this one's a, positive 2 and this one's a negative 2. And then here, the slope, definitely changed to about negative 1/2. So I'm going to go ahead and say slopes of corresponding segments may change. I'm going to go ahead and say reflections and rotations. So translations was the only one that stayed exactly the same. Corresponding segments in both pre-image and image are the same length. That would be all of them, kind of like how we listed all the things that they preserved. All of them have the same corresponding segments. What about parallel line segments in pre-image remain parallel in the image? That would include all of them as well, because that was one of the characteristics, again, that was preserved across all three of them. And angle measures of corresponding angles of pre-image and image are the same. Again, that would be all three transformations that we've learned this far. Okay, so at this point, let's go ahead and move on. It says number 2, triangle ABC has been plotted below. A, reflect triangle ABC over the y-axis and label the image A prime, B prime, C prime. So real quick, it's asking us to reflect it off of the y-axis, which is this axis here. So just a quick reminder, if you've forgotten how to do that, you just check to see how far is it apart from the line. So it's 2 to the left, so I'm going to go 2 to the right. Here it's about 6 away, so I'm going to go 6 in the opposite direction. Here it's 3 to the left, so I'm going to go 3 to the right. And that's going to go ahead and make the new shape for me. So notice I did label it A prime, B prime, C prime. Now second, it says reflect triangle A prime, B prime, C prime over the x-axis and label the image triangle A double prime, B double prime, C double prime. So let's go ahead and do that. Now they're asking us to do it across the x-axis, which is this axis here. So I'm going to go ahead and do that. So here it's 1 apart, so I'm going to go in the opposite direction. This one's 4 apart, so I'm going to go in the opposite direction. This is 3 units away, so opposite direction. And there is my new shape. So notice I'm labeling A prime, B, A double prime, B double prime, C double prime. So notice something I did was I labeled the points afterwards. I highly suggest you do it as you go. It's going to be easier for you to know which points rather than plotting all the points and trying to label afterwards. Okay, so the next question is, what one transformation is the same as this double reflection? Well, look at that. That is a 180-degree clockwise or counterclockwise. It really doesn't matter. They're basically equivalent rotations about the origin. So notice these two reflections across the y-axis and the x-axis is the same as a 180-degree clockwise or counterclockwise rotation about the origin. Okay, number 3, triangle DEF has been plotted below. Reflect triangle DEF over the line x equals 1 and label the image triangle DEF. So the very first thing I want to do is actually plot the line. Okay, for some of you, you're able to understand, okay, that's just a line cutting through the x-axis at 1. Some of you do get a little confused about that. So the easiest thing to do is write 2 ordered pairs that are true, where x is 1. So I'm going to put x is 1. Then you get to pick any other number that you want because there's no restriction on y. So I'm just going to say 0 and 2. So if you plot that 1 comma 0 and 1 comma 2 and draw your line in, there's your line of reflection. So at this point, go ahead and reflect. This is 3 units away, so I'm going to put 3 units away in the opposite direction again, label it. Here, this one's 1, 2, 3, 4 units away, so 1, 2, 3, 4, E prime. And last but not least, 1, 2, 3, 4, 5, 6, 7 units away, 1, 2, 3, 4, 5, 6, 7 units away, D prime. And then draw your line. Okay? So at this point, the next step would be to reflect triangle D prime, E prime, F prime over the y-axis. So don't be fooled, it is right here. So there are 2 vertical lines, that happens. I'm going to repeat the process. I'm going to reflect. So here it's 1, 2, 3, 4 units away. So I'm going to go in the opposite direction. 1, 2, 3, 4. Call that F double prime. Here it's 1, 2, 3, 4 units away. So 1, 2, whoops, just kidding. Starting from the y-axis, not this, not the x equals 1. So 1, 2, 3, 4, 5. So opposite direction, 1, 2, 3, 4, 5. And call that. We have 1, 2, 3, 4, 5, 6, 7, 8. Opposite direction, 1, 2, 3, 4, 5, 6, 7, 8. And call that D double prime. Go ahead and draw your line there, and there you have it. So the next question is, what one transformation is the same as this double reflection? So forgetting about this right here, how could I get this original DEF to D double prime E double prime F double prime? Well, it looks like it's just a translation. It seems like it's being moved over 2 to the left. So notice 1, 2, and voila. So basically, this is also a translation 2 units to the left. So notice there might be more than one way to describe it. It could be described as 2 transformations, or it might be able to be summed up in just 1 transformation. So now the last question says, write a coordinate rule for the transformation triangle DEF to triangle D prime, double prime, E double prime, F double prime. So what is happening? Well, let's think about it. Like we said, it's just basically 2 units to the left. So I'm going to go ahead and write, okay, we start with X and Y, and that will become, let's see, it's going 2 units to the left. That is of a movement according to the x-axis, so I'm going to go ahead and put x minus 2, but the y's did not change. It didn't go up, nor did it go down, so I'm going to keep it the same. I'm just going to put comma y. So let's clean that up a bit. It looks like that. Okay. So now moving on, number 4, QUAD has been plotted below. Reflect QAD over the x-axis and label the image Q prime, U prime, A prime, D prime. So the first thing we're going to do is identify the x-axis and go ahead and reflect it across that axis. So here, D is 3 units apart, so 3 in the opposite direction, D prime. Q is 1 unit apart, so Q prime goes there. U is 1 unit apart, U prime. And then A is 3 units apart, so here is A prime. And then just go ahead and connect those points together, and there you go. So the next part says translate QAD according to the rule x comma y yields comma x plus 9 comma y. So what this means is it's moving 9 to the right because x is referring to a left and right motion. And y, nothing is happening to it. So you can think of it as y plus 0. So it's not going up and it's not going down. So essentially, I'm just going to take Q prime, U prime, A prime, D prime, and move it 9 to the right. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's our new point. I'm going to go ahead and label it Q double prime, U double prime, A double prime, and D double prime. And that's all there is to it to this one. Okay, so number 5. In the picture below, triangle 1 has been transformed to obtain triangle 2. Which two transformations in succession can carry triangle 1 onto triangle 2? And then B says, which one transformation would carry triangle 1 onto triangle 2? At this point, I'd like you to go ahead and pause the video and try this one by yourself. Okay, so let's see how well you did. Here are some suggestions. You might have a different answer that could work. However, these are the answers that I have come up with. You can think of it as a reflection over the y-axis and then a reflection over the x-axis, or vice versa. You can kind of put these in the opposite position and still be exactly the same. For the one transformation, this is basically equivalent to a 180-degree rotation, counter or clockwise or counterclockwise. Both of them are the same. Okay, so now number 6. So same instructions. Find two transformations to carry triangle 1 to triangle 2, and then find one transformation that can do the same thing, carry triangle 1 to triangle 2. So go ahead and pause the video and try this one by yourself. Okay, so let's see how we did. For the true transformations I came up with, you can think of it as it's translating 1 down followed by 5 units up. Okay, so you can think of it as two separate translations. Okay, or you can think of it as a reflection across y equals 4 and then a reflection off of y equals 6. Okay, so again, answers may vary, so just keep that in mind. But what one transformation can make this happen? Well, just one translation would work. Okay, move it 4 units up. Okay, number 7. Okay, so this one's a little bit more tricky. So go ahead, describe a transformation or sequence of transformation that would carry triangle 1 onto triangle 2. Go ahead and pause the video and try this one by yourself. Okay, so let's see how we did. I came up with, it's a translation 3 units up followed by a reflection across the y-axis. So let me demonstrate. Here, 3 units up and then a reflection. Now, could you have reverses? Can you say first do the reflection across the y-axis and then do 3 units up? Absolutely. It's the same thing. Number 8, describe a transformation or sequence of transformation that would carry triangle 1 onto triangle 2. So once again, go ahead and pause the video and try this one by yourself. Okay, so let's see how well we did. So here, please understand you may have came up with a different series of transformation that may also work. However, this is the one that I came up with. I saw it as a reflection across the line y equals 2. So there's a reflection there. And then from there, it's moving 7 units to the right. So that is my sequence of transformations. Now, could some of you have come up with a different one? Absolutely. Okay, so don't feel like there's only one answer. Okay, so that is actually going to conclude the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.